Essentials of Biology students, BIOS 115, how y'all doing today? This, as always, is Karen Klein, and I am your instructor for this course and for this lab. Here we are again, and we are going to investigate, dig a little bit deeper as far as cellular respiration and fermentation is concerned. You, of course, are not new at this. You know, you have your lab downloaded and on your screen or in your hand, and you've read through the background on this, so I won't get too deep into it. But as far as cellular respiration and fermentation are concerned, as you recall that cells use ATP for their energy source. And so how they make ATP is by the breakdown of certain food molecules, and we refer to this process when oxygen is involved is called cellular respiration. While it happens in all food molecules, glucose is just like the easiest pathway to show you for a teaching tool, which is why you always see glucose. Now, glucose obviously is not the only food molecule that this occurs with. But we'll kind of back up a little bit. You see here on page 1 that cellular respiration occurs in 3 steps: glycolysis, the citric acid cycle, and then oxidative phosphorylation. Right? I'm hopefully pronouncing that right. I haven't learned after 20 years on how to pronounce that. Now, fermentation is the formation of ATP, but in the absence of oxygen. So really only glycolysis occurs here, if you recall that from reviewing that from your text material, your textbook material, and answering your questions for the homework. And so that's what our lab is focusing on, is rates of fermentation using 2 sugar sources. Now, the rates of fermentation, the organism that we're going to use is the rates of fermentation of yeast. Yeast are single-celled fungi. And during the process of fermentation, as you see there on page 1, the chemical reaction that occurs, the byproducts of fermentation of yeast in the presence of glucose is ethanol, which is an alcohol, carbon dioxide gas, and then there's your ATP. Now, for thousands of years, we've had this figured out, although we didn't know the exact process as far as yeast fermentation, because those byproducts we've harnessed for our own use. The ethanol, or the alcohol that's produced in the fermentation of yeast, is what gives us our alcoholic drinks. Sure, like the fermentation of the yeasts that are on the skin of grapes gives us wine. The fermentation of the yeasts that are associated with certain grains gives us the alcohol that is produced, or that is part of different types of liquors like whiskey and vodka and beer. Now, we also have learned for thousands of years that the carbon dioxide gas that's produced in yeast fermentation can be used to our advantage. And that is, if you've ever, I'm sure you all have, you're all over 18, I'm guessing, or 16 and above anyway. I know we have some high school students here. The production of that carbon dioxide gas is what causes bread to rise. And, like sandwich bread or rolls or English muffins or cinnamon rolls. Now, we also have, incidentally, quick breads, which uses, like, if you make corn muffins or banana bread or cupcakes, you would usually use baking soda or baking powder, which is a totally different chemical reaction that produces gases for that bread to rise, or for those products to rise. But before we discovered those products, we did have to use yeasts that produce this gas for birthday cakes and cupcakes. So even on the British Baking Show, they have a challenge where they have to make a birthday cake using yeast instead of baking soda or baking powder. But anyway, I digress. Now, specifically what you will be doing today is you'll be measuring the rates of fermentation of glucose versus sucrose. So 2 different yeast fermentation specifically, using these 2 different sugar sources. And you're going to determine using your data that you collect which is more efficient at fermentation of yeast, whether glucose is used as a source or sucrose. So therefore, number one, that's your hypothesis. So is it going to be glucose or sucrose? And I'll give you a little bit of a hint here. You know what? No, it won't. I'll have you figure that out on your own. Sorry, that it wasn't mean, but you're a student. You'll figure it out on your own. I'll get to that point. So here's what we're going to do. We have an Erlenmeyer flask, and we have a gas syringe. And we're going to measure the rate of gas, carbon dioxide, that's produced over a period of a minute. And our gas syringe is going to collect the gas that's produced. The first experiment we're going to do, and I should interject here that you're going to record your data in table 1 at the bottom of page 2. Okay, so what we're going to do, well, we have to find our reagents. This setup is used for lots of different, there's our yeast. So we're going to put the yeast in first. We're going to put in 50 mLs of yeast. And as soon as we add first we're going to do the glucose. There we go. Oh, we're going to add the glucose, and we're going to put that syringe on there, and we're going to note the time. I've recorded this now probably 7 times. I've had to keep doing it over because I keep making mistakes, whether it's a technical issue or an issue with the procedures, the virtual lab. And the last time I did this, I forgot to time it. So I'm back and I'm timing it. So, all right, going to put the glucose in, and it's up, and it's 750. Woo! Okay, let's put that syringe on, and it's going to be 850 that we are going to take the final reading of the syringe. Anyway, the hint I wanted to give you, because you're going to need it when you draw your conclusions, is you want to look up the structure of sucrose versus glucose. How many molecules big are they? And it's a ring-like structure. So, like, put them side by side. You Google that and look up glucose and look up sucrose and why one might be faster at fermentation rate than the other. As I'm sitting here making small talk, waiting for it to be 8:50. For that minute to elapse. We're almost there. Okay, and come on. 7.27. That's what you want to record. 7.27 milliliters. So record that in table 1. Let's now do sucrose. Okay, let's get our Erlenmeyer flask. And here's our sucrose. It doesn't matter what order you put it in. Okay. And let's get our yeasties, our little yeasties, our 2% yeast. And are we prepped? 9:25 is our time. So we want, we're going to go ahead, add, and there it is. Okay, so 10:25, we're going to check that. When we do this wet lab in the laboratory, it's actually a lot of fun. And the contraption is very similar to this, as what you see here in the virtual lab. And what we do in addition, but I don't see it as an option here, is we test things like artificial sweeteners and honey and corn syrup, and then we subject the fermentation where we only use glucose, but we subject it to like different pH regimens and different saline regimens. It's actually pretty cool, but we're a little limited here with our virtual lab. But I think you get the hint as far as the basics of fermentation. So I said 10:25. We're going to take this reading. Again with the small talk. Oh, come on. 9.38. Okay. You want to record that. 9.38. And very good. All right. Okay, so go ahead and write that in. And you want to record that on your table. And you will then go ahead and put that in the submission link. And you will get your lab points if you fill that out right. Okay, guys, everybody take care, and we'll see you soon. Bye.